Welcome to Aptitude for Placements, and my name is Ranjit. I have conducted this aptitude training program at various engineering colleges all over India, and every year thousands of students get placed by attending this aptitude training program. Here you will find all the questions that are commonly encountered in most of the aptitude tests. These are the questions that keep on repeating in many of these tests. So just familiarize yourself with all these questions and you will have a clear advantage when you attempt your actual placement test. Let's start. 6 points are marked on the circumference of a circle. How many triangles can be formed using these 6 points? So you have a circle like this and 6 points are marked on the circumference of this circle. So 6 points like this. So you can see that you cannot draw a line that will touch 3 points. So if you take any 3 points, they will not be collinear. So basically what it says is that you have 6 points and no 3 of them are collinear. And how many triangles are possible? Requirement for a triangle is 3 non-collinear points. So out of the 6 you can choose any 3 because no 3 of them are collinear. So altogether 6 points are there. Out of the 6 you can choose any 3. This many sets of 3 non-collinear points can be chosen and that many triangles are possible. So there will be 6C3, 6 into 5 into 4 divided by 3 into 2. 3 into 2 will cancel with 6. So remaining 5 into 4, 20. So altogether 20 possible triangles are there. Option C, 20. There are 12 points in a plane out of which 5 are collinear. Find the number of triangles you can form with the points as vertices. Now altogether 12 points are there and 5 of them are collinear. And how many triangles are possible? Now the process for doing such questions is like this. First we will assume that of the 12 points, no 3 of them are collinear. And we will find out the total number of triangles that are possible. And from that we will remove all the triangles which we could not form. Here 5 of them are collinear. For example, if you have 3 collinear points, collinear means they lie on a straight line. So if you choose these 3 points, you cannot form a triangle. You will get only a straight line. So there are these 5 points which are collinear. And because of that, we will not be able to form certain triangles. Now those triangles which we could not form, we will subtract from the total number of triangles. So altogether 12 points are there. We are assuming that no 3 of them are actually collinear. So total number of triangles possible are 12C3. You can choose any 3 from the 12 because we are assuming that no 3 of them are collinear. So this is the total number of triangles that would have been possible. From that we'll subtract the number of triangles which we could not form because 5 of them are collinear. Now the triangles which we could not form are these 5 of them are there. Now if you choose any 3 out of these 5, you will get only a straight line. You will not get a triangle. So these are the triangles which we could not form. That we will subtract from the total number of triangles that we could have formed. Then we will get the triangles which we can actually form. So 12C3. So that will be 12 into 11 into 10 by 3 into 2 minus this 5C3. So 5 into 4 into 3 by 3 into 2. Now 3 into 2, 6. 6 divides 2 times. So 2 into 11, 22 into 10, 220. That is 2 into 11, 22 into 10, 220 minus this. 3 and 3 will cancel out. 2 divides 2 times, 5 into 2, 10. So 220 minus this 10, altogether 210. This many triangles are possible. So option C. There are 10 points in a plane, out of which 6 are collinear. Find the number of triangles you can form with the points as vertices. Now altogether 10 points are there, out of which 6 are collinear, and we need to find out the total number of triangles that can be formed. Now the process for doing such questions is like this. 10 points are there. First of all, we will assume that out of the 10, no 3 of them are collinear, and we will find out the total number of triangles which we could have formed, and from that we will remove the number of triangles which we could not form, because these 6 of them are collinear. So requirement for a triangle is 3 non-collinear points. So let us say 3 points are there on a line, then they are collinear. If you choose these 3 points, you will not get a triangle, it will only be a straight line. If you choose 3 from these 6 points, you will not get a triangle, because you will get only a straight line, because they are all collinear. So first we will find out the total number of triangles which we could have formed, assuming that no 3 of them are collinear. So from the 10 you can choose any 3. This is the total number of triangles which we could have formed. From this we will remove the number of triangles which we could not form. That is, these 6 of them are collinear, and you can choose any 3 from these 6 and you will get only a straight line. You will not get a triangle. So these are the triangles which we could not form, that we will subtract from the total number of triangles which we could have formed. So that will be 10C3. So that is 10 into 9 into 8 by 3 into 2 minus 6 into 5 into 4 by 3 into 2. 3 divides 9 3 times. Here it is 4 times. 3 into 4 12 into 10 120. 3 into 2 divides 6. 5 into 4 20. So 120 minus 20 you will get it as 100. Hence 100 possible triangles are there. Hence option A 100. A straight line has 5 points marked on it. Another straight line has 4 points marked on it. Making use of all these points, how many triangles is it possible to form? Assume that both the lines are parallel. So you have 2 parallel lines. In one you have 5 points, and in the other you have 4 points. So here there are 5 points, and in this line you have only 4 points. Totally how many triangles are possible? Now the requirement for a triangle is 3 non-collinear points. So if you select any 3 from this 5, you will not get a triangle. Similarly, if you choose any 3 from this 4, you will not get a triangle. It will only be a straight line. Now to get a triangle, you can choose any 2 from this 5 and 1 from 4. Or you can choose any 2 from this 4 and 1 from 5. These are the favorable cases when you get a triangle. So from this 5, you can choose any 2 and the remaining 1 from 4. 1 from any of these 4. Then you will get 3 non-collinear points. Or you can choose any 2 from this 4 and the remaining 1 from this 5. Then also you will get a set of 3 non-collinear points. So 2 from 5 and 1 from 4 you have to multiply. Or you can choose 2 from 4 and 1 from 5. So this and this, or this and this. So we'll just solve 5C2. So that will be 5 into 4 by 2 into 4 by 1. Or 4C2. 4 into 3 by 2 into 5 by 1. So 2 divides 2 times. So 5 into 2 10. 10 into 4 gives you 40. Here 2 divides 2 times. 2 into 3 6. 6 into 5 gives you 30. 30 plus 40, altogether 70 possible triangles are there. Hence option B 70. A straight line has 7 points marked on it. Another straight line has 5 points marked on it. Making use of all these points, how many triangles is it possible to form? Assume that both the lines are parallel. So you have 2 parallel lines. In one you have 7 points and in the other you have 5 points. And totally how many triangles are possible? Now requirement for a triangle is 3 non-collinear points. So if you choose 3 from this 7, you will not get a triangle, you will get only a straight line. Similarly, if you choose 3 from 5, you will get only a straight line. So the favorable cases are, you can choose altogether 3 points are needed. 2 of them can be chosen from this 7 and 1 from 5. Or you can choose 2 from 5 and 1 from 7. They are the favorable cases when you get a triangle. So from this 7, you can choose any 2 and the remaining 1 from this 5. Or you can choose 2 from 5, any 2 from this 5 and 1 from this 7. So 2 from 7 and 1 from 5. So you have to multiply. Or 2 from 5 and 1 from 7. So this and this, or this and this. So let us calculate the total number of outcomes. That is 7C2. 7 into 6 by 2 into 5 by 1. 5C2. 5 into 4 by 2 into 7. Here 2 divides 3 times. So 7 into 3, 21. 21 into 5 gives you 105. Plus 2 divides 2 times. 5 into 2, 10. 10 into 7 gives you 70. So 105 plus the 70, altogether 175. So 175 is the final answer. This many triangles are possible. Hence option D, 175. Let me briefly explain how to prepare for your aptitude test. First of all, you need to familiarize yourself with all the questions that have been worked out here. These are the questions that keep on repeating in many of the aptitude tests. After that, you need to attempt practice tests. According to me, you need to attempt at least 10 practice tests before your actual placement test. Here, I will be giving you 10 practice tests, and these practice tests will be ideal for you to improve your test scores. The 10 practice tests are available at a cost of only Rs 200. So all that you need to do is make a payment of Rs 200 either through Google Pay or through Phone Pay or through Paytm, and you will receive the 10 practice tests. The details of the payment comes next.